Our next topic is Euler circuit or cycle and path. So what is an Euler cycle? It is a cycle that contains every edge and every vertex of G. Now, what is Euler path? Euler path is a path with no repeated edges, but it is possible to have repeated vertices containing every edge and every vertex of G. And we will show you later what are the conditions that we need to check if an Euler cycle or Euler path exists. This is a definition, and usually we will use this definition for testing whether an Euler cycle exists or not. It says if a graph has an Euler cycle, then every vertex of the graph has an even degree. So if we know that the graph has Euler cycle, then the result we will have is that every vertex will be of even degree. This is if and then. So from right to left, not necessarily true. So if you know that every vertex in a graph, the degree is even, then it's not necessarily it has an Euler cycle unless we have a condition which we will cover it in this definition. This is now the contrapositive for the definition we have in here. So we will use this for testing whether a graph has an Euler cycle or not. It says, now see, remember the contrapositive? You swap the hypothesis and conclusion, and you take negation both sides. So what's negation for every vertex of the graph has an even degree? So if there is a vertex of an odd degree, then the graph has no Euler cycle. So this can be used for testing that a graph does not have Euler circle. Now what will be the condition we should use to verify that a graph has an Euler cycle? It says, if every vertex of a graph has even degree, and if the graph is connected, so this is the other condition we should add to this definition. If every vertex of even degree and the graph is connected, then the graph has an Euler cycle. So if you want to check that the graph does not have Euler cycle, find one vertex of odd degree. If you want to verify that the graph has an Euler cycle, then check it's connected and every vertex has even degree. Now for Euler path. A graph has Euler path between two vertices U and V, and usually we check for Euler path if Euler cycle does not exist. So an Euler path between two vertices U and V exists if G is connected, the graph is connected, and all vertices are even except U and V. So if you have a graph that's connected and all vertices are of even degree except exactly two, not one, exactly two, then there is a path between U and V. Let's go for an example. Now if I want to test if this graph has an Euler cycle or not, first I need to check, is it connected? Yes, connected. There is a path between any two vertices. And let us check now the degrees. This is degree 4, which is even. Now this is degree 3, so it is odd. So we can use this one as a test for that this graph does not have Euler cycle or circuit because degree of V3 is equal to 3. Now for the second one, the second graph. Now for this graph, it is connected because all vertices, between two vertices, there is a path. And if we check all vertices, they are even. So 2, 4, 2, 4, 6, 4, and etc. So all vertices are of even degree and the graph is connected. So how to find Euler circuit? To find Euler circuit, we start with one vertex and try to come back to this vertex. So we will start from C and we will go to D, and then we will go to B, and then we will go to E, and then come back to D and C. D is repeated, that's fine because it's a cycle that we should not repeat edges. And then we go to H, again go to E, go to G, come back to H, then go to I, then you go to G, then you go to F, from F you go to E, from E you go to A, and from A you go to B, and from B you come back to C, and this is the Euler cycle. Of course, it is not unique because it depends from where you start, but maybe you can have an observation if you have a triangle, that see if you have a triangle, then the arrows are following each other in each triangle. And this exists because we have an Euler circuit. Now let's come back to our example here. Now how many vertices of odd degree? Now this is 1 and this is 2. This is even and this is even. And since we have exactly 2 of odd degree, then there is an Euler path between these two vertices. So there is an Euler path between this vertex to this vertex, and it will cover all edges. Let us find this Euler path. So we will start from V3 and we will go to V2. And then from V2, we will go to V4. And then we will go to V2. Now, from V2, we will go to V1. And from V1, we will go to V3. And from V3, we will go to V4. And finally, from V4, we will go to V1. So we have moved from V3, and we have reached V1. And as you notice, we don't have repeated edges and it covers all vertices. So this is Euler path and this is Euler cycle or circuit. That's all for today's lecture. Good luck and see you in the next lecture.